So as Lacey said, this is a presentation on using Ansible for device compliance. And I would like to correct one thing. I was a developer advocate. Now I'm a technical advocate with learning and certifications. You can find me at Snyder on all the socials, GitHub, LinkedIn, and Twitter for more content like this and my overall musings and ramblings. So for today, I want to take a step back and talk about what a holistic view of compliance is. So when we think about compliance, a lot of us think of we're enforcing a configuration baseline. So I have a configuration, I have a device, I need to make sure that those two things are in alignment so my device is quote unquote compliant. But if we think about a device's life cycle in our network, it's not just about a single enforced configuration. We have a life cycle. We have to make sure that those configs are archived. We have to make sure that we can selectively change pieces of our config. SNMP strings, maybe we've got users, passwords. Suddenly, summertime dates have changed as they seem to do every year. So we need to make sure we can selectively apply that configuration to devices. And as a show of hands, how many of you have to submit a change request to a CAB or change advisory board with detailed configurations? They're gone over by tons of network engineers, and every single line is picked apart. Show of hands. Okay, most of you. What if I told you that we can simplify that and you don't have to do any work about moving from Ansible playbooks into code? You can use the same thing. We can render config. So we'll talk about that, and then we'll look at configuration drift and deltas from a baseline. So all of these different things can go into compliance, because as network engineers, compliance isn't just the device, it's our process, it's our procedures, it's making sure that everything is all in line. So why would we use Ansible for this? First of all, it's declarative. So I don't have to worry about specific syntax. I can write in natural language, or as natural as YAML can be. Lots of tabbing. It is important, and I'm calling this out, that it's task level declarative. I'm not worried about specific configuration pieces, so I'm not doing IP route blah. I'm using the IP route module with specific attributes that gets assigned to it. That makes it declarative, not imperative. Do not believe everything you read on the internet. Ansible is declarative, but it's at the task level. I have to know how to get from point A to point B myself, which is different than end-state declarative tooling, something like Terraform. It's idempotent, and if you haven't heard that word before, you will now. But usually that's the thing that people talk about with Ansible. It's I can write something, I can apply a configuration to a device, and it doesn't matter whether or not I have run it one time or 1,000 times. It's not going to add those 1,000 times that config. It only runs it once, checks it, verifies if it's in a state that it needs to be, then it won't apply any new config. Ansible can also, with the revamping of the network state modules, I don't have to worry about how to write an undo action with Ansible. So if you've not looked at the Ansible collections for Cisco iOS, Cisco NXOS, and other platforms recently, you'll see a new attribute that gets assigned, and that's the state attribute. We have a variety of states: replaced, deleted, rendered, merged, things like that. But that way, if I need to apply a config and then remove that config, I can do the same thing with the same module just by changing that state. So there's no complexity in applying a config versus removing a config, because I just changed that state. So it makes it very easy to do. And then finally, we can do programmatic things, conditional matching templates. We can do partial playbook runs, et cetera, et cetera. So in this presentation, we're going to explore how many have used Ansible 2.10 or above, and you're familiar with collections. That's actually more than I was expecting. So we'll talk, for those of you who are unaware, Ansible has changed from 2.9 to 2.10 with how the device modules are grouped and included. So we'll talk about that. Configuration backup, variable precedence, and I've got a little trivia that might blow your mind. How to use task tagging, rendering config, using roles, and hopefully we have time to do some diffs. And all of this can be done using the DevNet Sandbox, the small version of CML, you can have that reserved for up to 2 days, so you have a lot of time to play with it. So before that, let's jump into the lab. And all right, so let's clear this. Okay, so I'm just connected to a VPN to my Ansible sandbox. I'm going to start just to make sure that I go through a few pieces real quick. First of all, everything with Ansible has to use an Ansible.cfg. You can have one as a default in your Etsy directory, or because I'm a developer, see I have all the stickers, it means I'm a developer. I like to keep folders as projects. So in order to do that, I have to modify my Ansible config to make sure that everything is self-contained. So I have my inventory that's local to this folder. I have my role folder, which is local again, and then I have my collections folder, which is local to this. That way, if I change folders or create a new project, yes, I have to go through the process of re-downloading all those things, but I can keep them separate if we have some issues with new collection versions, or maybe I'm changing something with a role. I can keep that self-contained. From an inventory perspective, real simple. We're just connecting to these using the network CLI method. I'm using my local virtual environment Python editor to make sure that I have the right Python version. And then I've just defined my devices. We have 2 iOS XE routers. We have defined their network OS to be cisco.ios.ios. This is important. A, because if you don't define this, it probably won't connect. But B, we can do conditional matching, which I'll show in the next playbook, so that we only apply the task when the OS matches what we desire. I have my username and password, again, clear text. This is a lab. I'm not necessarily concerned about security, but that's what's in clear text there. And we have 2 NXOS devices. And again, I've matched that network OS to be NXOS. And then I've created this all pods meta grouping. So if I wanted to affect change on all of these devices, I can call the all pods iOS XE and NXOS. The important part here, though, is that just because I call all pods, because each subsequent child is matched in that network OS statement, I don't have to worry about that anymore. It will automatically figure out, oh, these devices are iOS, these are NXOS, because of how I have them defined in my inventory file. Okay, the first part of this, and this is the important part about Ansible 2.10. I already have these collections installed, but I'm going to go through the process to show you what you need to do in order to connect to these devices first. So in Ansible pre-2.10, the Cisco core modules, so iOS, NXOS, and other network vendors were all included when you did a pip install for Ansible. It made it bloated, like 500 megs worth of download over pip, but you had everything you needed. It was batteries included. After 2.10, Ansible core only ships with a very, very small set of modules. A module is what you need to connect to your device. In order to install the modules for something outside of Ansible core, you must use Ansible Galaxy to install those modules. So that syntax is Ansible Galaxy install collection, and in this case, I'm going to do cisco.ios. So I'm reaching out to my Ansible Galaxy, which is like the main registry for all Ansible modules. I'm installing the collection called cisco.ios. And it's going to go through this. Oh, I have that backwards. It's collection install. So it's going to reach out to Ansible Galaxy. It's going to see what is out there, if there's any dependencies. I'm already up to date. If there was an updated version, I would have had it would have downloaded that for me. And likewise, I would do the same thing with NXOS, and this one hasn't changed either. So it should just say we're good to go. If I didn't have these collections present, before I could connect to any Cisco iOS or NXOS device, I would have to make sure that they were installed. And you can see I have those collections here under my local collections folder in that project, and it is installed Ansible Netcommon, which is kind of like the SSH library pieces are installed in this folder, and then the Cisco main tag, so I have iOS and NXOS. So all of those are there already. Now I can connect to my devices. My first step is always, I like to do a test, and this is a great way to check to make sure that everything is up and functional. All I'm doing is testing, do I have reachability to my devices? I also happen to be gathering the configuration and parsing that into a bunch of variables if I chose to use them later on using the fax module for iOS and NXOS. So I'm gathering the entire running config of that device. I'm going to parse it out. But here's what's really important when we start working with Ansible in larger networks, is the when flag. By using when, I'm saying only run this task when the Ansible network OS that was in the inventory file, so let me make sure this one stays and doesn't disappear. So in inventory, remember we've defined the Ansible underscore network underscore OS for each device type. So only run this task when the iOS matches what we defined. In this way, we make sure that our iOS devices have the tasks applied to them appropriately, the NXOS devices have those tasks run, and we can combine device types into a single playbook. So I don't have to worry about having a fax XE and a fax NXOS. I can combine them all together and just do conditional matching based on the OS to make them run. So I'm going to go ahead and run this Ansible playbook 99test.yaml. If you notice, I've got 10, 20, 30, 40. It makes it really easy to tab, but I was told this was supposed to be a basic course, and I ended up writing Ansible code. So bad programmer humor. I apologize. So we've got this, we're testing, we're seeing that we're gathering all these pieces. Everything is green, which means not only am I gathering all the facts, that means my VPN hasn't broken in the 13 minutes I've been rambling. So we all should be good to go. So let's go and start our compliance journey. We're going to start with something simple. We need to back up our configs. We need to have a point-in-time snapshot of what our devices have configured on them, because if we change something, we want to make sure that we can roll that back. This used to be a really complex process in Ansible. It's not anymore, because we have the config modules which support the backup attribute. So all I have to do is say when something is iOS or NXOS, and you can see, again, I have those conditional matches. Use the config module to perform a backup. We're going to be gathering the running config, put it in a folder called backup, and delineate that by inventory hostname. So our inventory hostnames are just the IP addresses that were in there. If we use DNS addresses, we could put it there. However we want to organize them in our inventory. But use the hostnames defined in our inventory file, and call that initial running config.cfg. So we're going to have 4 folders that get created inside of the backup folder, and each folder will have an initial running config. This is a very quick win. If you need to archive a bunch of configuration on a lot of devices, you can build your inventory file, write this, tie it to a cron job, and all of a sudden we have device backup in like 5 minutes. I actually used to use something similar to this when I ran the lab in Phoenix, Arizona, where I'm from, and I just had it dumped to a NAS or a SAN that was off-site, so I made sure that even if the lab crashed, I could restore it. So we'll begin by running this playbook. And I generally like to run it with at least one V, because I like the verbosity if something breaks. I know that these are going to work, but to each their own. So it's going to back up these configs to a folder. We can see that we have the backup folder that was created. And these are yellow, which means that something has changed. It's not green. It's yellow, so something has changed. Green and yellow are okay. If you see red, danger, something went wrong. But now we have this backup folder, and we have those delineated by IP addresses, and just like our playbook said, we now have a running config of every single device. Great. So we've started the first step of our compliance journey. I'm going to start another SSH window, Cisco at 175. Oh, let's see here, Vim. Let's try that again. Also, VI is one of the best editors, and I will live and die by that. Well, it looks like someone's changed my password. Someone might have jumped in here between runnings. This should be fun. Okay, so now we have this, our next step in our compliance journey, and I wanted to pull up the second terminal because I want to show you that we're going to do something really basic. We're just going to change the NTP servers on this device. So if I do a show run, and I'm doing this live, so yeah, so someone's created some servers. So someone is using my pod, even though I told them not to. It was Julio. I blame Julio. But what we're going to do here is we're going to change this we're going to do some stuff on the fly here. So right now we have some basic NTP configuration, but we're going to want to make sure that we enforce a baseline compliance. I'm using, again, that conditional matching. Ansible Network OS is iOS and NXOS. We're changing the NTP server, so that's what the NTP global module is. We're adding some servers based on some values that are going to be substituted in, and these are actually in the group vars folder for XE and NXOS. So we have 2 servers defined, and those will be applied to each set of devices. And we're going to change these. We're going to call these 100 and 101, because why not? Save both of those. So those variables have been added. The other thing that we're going to do is under the tags here, we're going to change the state. So like I said, we have these network states that are defined. Merged says take whatever exists and just add it to what we're going to apply. There's another state that we can do called replaced, or state replace, I believe, which means only enforce what is in there. So if there's other things that are there, remove them and only have this single items that we've defined in this playbook to on the device. The other thing that I have here that you may have not seen before is a tag. How many folks have used tags in Ansible before? Perfect. Tags are the greatest trick about Ansible that no one has ever, very few people know about. With tags, just like if I tag some other item, I can reference those things only by that tag. So in this case, I have a tag for a deploy action, and I have a tag for a, let me make sure that this gets done. I have a tag for a remove action. So I have this deploy and clean. What this means is I can have multiple items in a single playbook. I can have the forward and the reverse. Because I have those network state modules, that means that the forward and the reverse, all I have to do is change that one flag between the two. So when I call the -- tags deploy, it'll apply that config. When I do -- tags clean, it will remove those. So I have the forward and the reverse action in a single playbook. And we're going to, the last thing that is really great in our compliance journey is we want to make sure that when we apply a configuration, we know what it's going to do before we actually apply it. I know we should have labs. You all have a lab, right? We all have a lab. Let's nod our heads. We all have a lab. If you don't have a lab, I won't tell. But who here has heard of Ansible check mode? Another well-kept secret. All right. Check mode, or -capc or -- performs a dry run against our Ansible playbook. So what that means is if I run the playbook in check mode, it's going to say this will change. I'm not going to change it, but I'm going to show you what would change if I was actually doing that action. So between the check mode and the tags, I have a validation, I have a forward, and I have a removal action that I can put in a single playbook. Again, I've got some compliance there. So Ansible playbook, and we'll run in check mode first, 20 tags.yaml -c -- tags deploy, and you can chain those things together, which is great. So I'm doing check mode, but I'm doing the deploy action in check mode. So what this is saying is that there are other items that's going to be removed. Oh, where are we failing? Oh, it's replaced. That's why. I knew it was replaced. We're doing it live. All right, let's try that again. Okay, what this is saying is we now have these items that are going to be applied to this device. It's saying that we have this 10.10.2100, and here's what the servers are currently on that device. It's read the configuration, it's parsed it, said there's things that are there that shouldn't be there based on that replace. So it's going to perform these no commands and apply those to the devices, and then iterate through the other two. So we can see that everything worked. One was okay, one was okay, changed. Under normal circumstances, if I was to have this without check mode, those would have changed. It would have reflected what happened. But check mode just said, There's going to be changes that happen, but I'm not going to make them yet. So now let's run this without check mode and show you the impact. Just remove the -C tag. And now we're actually going to deploy these things. So it'll scroll through. We'll see that those the output from Ansible is still yellow because, again, it's going to actually make these changes because it didn't make them the first time. It's taking a little bit longer. It's going to iterate through. Both XE devices are done. Now we're onto our NXOS devices. And in the interest of time, show run INTP. I don't know why that second one didn't take. You can see we cleaned. This is why we test. Something didn't happen. It should replace based on the whole list, but maybe there's a bad loop in there again because I'm doing it on the fly. But if I was to do, just to illustrate the tags here, let's do the # tags clean. And we will see now that we're going to delete the NTP servers that we've created. So we'll run the clean action to show that it's only going to, if we look at the task names here, it's only going to be the remove action, remove the NTP configuration. When we have the state deleted, it goes through, and after it applies it, we're going to see that green come up afterwards, which means it read the config, made changes. Now it's going to verify that the changes actually happen and delete them, and then move on to the next step. So if we do a show run pipe INTP, those NTP servers have all been deleted. So again, same playbook. We have a forward and a delete action. When we talk about compliance, we want to make sure that it's not just compliance in our devices, it's compliance in our process. We know that we can use a lot of places for variables inside of Ansible. How many folks think that there's more than 5 places to put variables inside of Ansible? If I was to run a playbook, there's more than 5 places where I could stick variables. We got host vars and group vars and this and that and the other. So more than 5. How many think more than 10? And if you were in my session yesterday, don't raise your hand because your vote doesn't count. More than 10? More than 15? More than 20? There are 23 places you can put variables inside of Ansible. 23. In fact, if you Google Ansible variable order of precedence, you'll get an entire document, a listed document. Some of them are very esoteric and you may not use them, but they exist. And I'm going to use that fact to illustrate we have those group vars that we saw earlier. We also have variables assigned inside of our playbook, same variable name NTP servers. I'm going to go through and apply these. Let's see here, Ansible playbook 30 precedence.yaml. We're going to use the deploy action because the playbook is the same. We've just added those new variables, and we'll see Ansible Thunderdome of NTP servers, which one's going to win. So I have them defined in group vars and in the playbook at the very top as a variable, and we'll see that it actually is going to install the 3333. So the compliance isn't just the devices, it's make sure you have a process of where you're going to store variables in your playbooks, because if someone says, well, I see that there's a variable called out in the playbook, but it's not here, I'm going to put it at the top, you could have a bad time with your device configuration. So that's one important part. All right, I know we're getting really close on time, so I want to show one final thing about precedence. And if you would like to know more, you can come find me after this session. All right, change advisory boards. We all have them. Do they accept Ansible playbooks? Can you give them an Ansible playbook and they go, oh yeah, I know exactly what that is? No. But you want to automate. How can you bring the two together without having to translate Cisco configuration into a playbook and vice versa? Well, if we open this 40 render, using the state rendered inside of our Ansible tasks, Ansible will generate configuration for us and spit it to standard out. So all I have to do, again, is if I'm going to change the NTP server, let's do state rendered, show the output of that, gather that, change the state to merged or replaced or whatever we need to, and we're in business. We can satisfy our change advisory board requirements to have our configs, and we can also use Ansible for our automation. And in the interest of time, I'm going to skip ahead to something that maybe some of the the Encore and ENRC folks are going to shudder at, is prefix lists. They can be very complex, and maybe you understand them from a how to write them on CLI standpoint, but we want to translate that to Ansible. So I'm going to use the prefix lists module inside of Ansible, and I'm just going to build some prefix lists here, and I want to make sure that they're aligned to what I need to have applied. I'm going to run through and do, let's see here, Ansible playbook, 40 render YAML, --v, --tags, and we're going to call that prefix because that's how I have that tagged. You can see we're going to run through this, and my rendered config is right here. So Ansible has been used to generate the configuration, so I can copy and paste that. Obviously, you need to add some carriage returns, but that's exactly what the playbook's going to apply. I can copy and paste that into my change advisory board document, and I know that Ansible is going to do that because Ansible told me it was going to do that. So we can do that from a rendering perspective. There's a lot more in this. If you want to come find me after this, I can share the resource where you can have a lot more of this. I talk about how to do diffing, so we can diff between two configurations inside of Ansible, how to use roles, things like that. But you're really here for the raffle. You weren't here for my Ansible knowledge. So I am going to shuffle these up because this isn't fair that they're stacked in order like that in the cup, Julio. Come on, we need to be fair. And I am going to choose a random ticket. Last four, 9979. 9979. Oh, they weren't present to win. Take two. I like this one. I like it so much it almost fell in my hand. Last four, 9256. Gentleman in the back. So again, thank you all for your time. I know I didn't get to cover everything I wanted to, but you can find me at the time. If you hit me up on social, like you can tweet me, DM me, whatever,